Hi everyone, so we are going to start talking about using antiderivatives to find exact areas. So let's recap what we kind of already know so far. We can find exact areas using geometry. So that's the first thing that we did in this chapter. But then we realized that that really only works when we have nice geometric graphs. So we found exact areas doing that. So then we said, okay, well, we can approximate areas that aren't nice geometry ones using our approximations. So LRAM, MRAM, RRAM. So using rectangles or trapezoids. And we said that, okay, that'll at least give us approximations. Well, now we need to talk about how we find exact areas for any curve. All right, so if we don't have a geometric graph, how do we find these exact areas? And that's what brings us to the fundamental theorem of calculus. So you can tell just by its name, the fundamental theorem, that this is going to be really, really important as we move forward. Okay, this is one of the big ideas of calculus. So the fundamental theorem of calculus says that if f is continuous at every point on the interval from a to b, and if capital F is the antiderivative of f, then the integral from a to b of f of x dx is equal to the antiderivative evaluated at the upper bound minus the antiderivative evaluated at the lower bound. So I know that that sounds like a lot, right? The important part here to know is that f is the antiderivative. This capital F here means that it's the antiderivative of some function lowercase f. So we've spent the past day or so looking at antiderivatives and how to find them, and this is why. Because we're going to use that antiderivative to evaluate and find the exact areas under the curves. So let's see here. A is our lower bound, and you'll notice that that one actually comes second. All right, so if it's the integral from a to b, when we evaluate it and take the antiderivative, it's always the a that comes second. That's the piece that we're subtracting. All right, and then the upper bound, b, is right here. So this is the upper bound. Wow, I can't spell. I don't know why I put an A. Apparently, I need to go back and learn how to spell. And then this is the lower bound. Look, that time I spelled it right, guys. Aren't you proud of me? Okay, so anyway, let's look at what this actually looks like then. And by the way, you'll notice that we are subtracting, okay? So let's take a look at what this actually means and looks like in a problem. So use antiderivatives to evaluate the following integrals. So number one is the integral from 0 to 3 of 2x minus 2 dx. So let's take a look here at what our function actually is. So our function is 2x minus 2. So that's our f of x. All right, we need to find the antiderivative of that. We luck out that this one is a really nice, just undoing the power rule, which means when we look at this, we would have x squared minus 2x, and then we have our plus c. So you should pretty quickly be able to do that. And then I've got this new notation for you. We talked about it a little bit once upon a time, but we're going to evaluate it from 0 to 3. So we write the antiderivative and then we draw this line and we put our lower and upper bounds, so 0 to 3. All right, so what this means is now we're going to have to actually evaluate it. So we always take the upper bound first. So I'm going to take the 3 and I'm going to substitute it into my function. So it's 3 squared minus 2 times 3 plus c. And then I have to subtract my lower bound, right? I want to subtract capital F of A. So since this is my capital F, I'm going to subtract that, and we're going to plug in 0. So now we're going to have 0 squared minus 2 times 0, and then plus c. Sorry, I'm going to have to extend those parentheses. I don't know why I drew them so small. Okay. Now, the important part here is we're going to have to distribute this negative. That's why the parentheses are there to begin with, okay? So let's actually evaluate it and see what happens. So 3 squared is 9, minus 2 times 3, so that's 6. So 9 minus 6 is 3, plus c, minus 0 squared is 0, minus 2 times 0, which is 0. So then we have this minus c, all right? And if you notice, the c's cancel, and we're left with 3, which means the integral from 0 to 3 of 2x minus 2 dx is just 3. All right? The c's are always going to cancel. If they don't, then it means that something in your problem isn't right. So maybe you didn't distribute or something along those lines. So we'll talk more as we move through about how where that might happen, but you want to be careful and make sure you actually distribute correctly. Now, this particular example, we can actually draw a graph and see if we're correct. So 2x minus 2 is a pretty easy graph to draw. So we have a line that has a y-intercept of negative 2 with a slope of 2. So up 2 and over 1, up 2 and over 1, up 2 and over 1. So we have, if I could space it out correctly, we have this line, and we want to find the integral from 0 to 3, which means we want this piece here, which is underneath the x-axis. So that's a base of 2 and 1, or a height of 2 and a base of 1. And then we have from 1 to 3, we have this area here. So this is a base of 2 and a height of 4. So we can go ahead and actually find those areas. So this piece here is going to be a negative 1/2 times 1 times 2. And then plus the red part, which is 1/2 times 2 times 4. And so we get negative 1 plus 4, which is equal to 3. So we can actually check this one using our geometry. Now, we're not going to do that like ever again. I just wanted to show you guys that this is where this is coming from, and it's what it's showing us, okay? Now, most of the time, these kinds of questions are going to be no calculator, but I do want to show you guys really quickly how to do this on your calculator, just in case you are actually able to use your calculator. So, go ahead and grab your calculators, and we're going to hit the math button, and we're going to scroll all the way down to number 9, which says FN int, okay? So if we hit that, and if you've got the math type, it actually just shows us the integral. So we're going to go ahead and put this in. So the integral from 0 to 3 of 2x minus 2, and we want to have a dx right here, and if we hit enter, it's 3. Okay, so again, you have to show all of your work. These are no calculator questions, but I do want you to know how to check it on your calculator just in case it happens to be something we are able to use your calculator. All right, let's go ahead and race through a couple more of these examples. So, in number 2 here, the first thing we need to do is find the antiderivative of 2e to the x. And hopefully you guys can look at that and you can recognize right away that that would just be 2e to the x plus c. And we're going to evaluate from negative 2 to 0. All right, so let's see. We're going to go ahead and evaluate. We're going to plug in our upper bound first. So 2e to the 0 plus c minus, and we want parentheses here, 2e to the negative 2 plus c. And we're going to distribute the negative here, and let's start to simplify. We know that e to the 0 is 1, so this is really 2 plus c. And now I can distribute my negative in here. So we get minus 2e to the negative 2 minus c, and there we go. Our c's cancel each other. So we get that this integral is equal to 2 minus 2e to the negative 2. And there's our final answer. All right, we are not going to do all of them on this page. We're just going to do a couple of them so that you guys can kind of see how this goes, and then we'll do some in class together. So question number 3, it's the integral from pi over 6 to pi over 4 of secant squared x dx. So hopefully you can look at that and recognize that the antiderivative of secant squared of x is tangent of x plus c. And we're going to evaluate from pi over 6 to pi over 4. All right, so again, if you recognize your antiderivative rules, you're good to go. All right, now let's evaluate our upper bound, tangent pi over 4 plus c, minus, we're going to evaluate at our lower bound, so the tangent of pi over 6, and then plus c. I know that the tangent of pi over 4 is 1, so I have 1 plus c, minus, let's see, the tangent at pi over 6 I know is going to be 1 over the square root of 3, and then if I distribute my negative I have a minus c, so these cancel each other, which means I'm left with this integral being equal to 1 minus 1 over the square root of 3. Now this might be a nice one to actually check on our calculators. So I'm going to go ahead and grab my calculator, and the first thing I'm going to do is actually figure out what this is as a decimal. So 1 minus 1 over the square root of 3. So when I evaluate this integral, it should be roughly 0.4226, okay? Let's check and make sure that this is in radian mode. Okay, we're good. So we're going to do math, and we're going to hit number 9 so that we get our integral. And we're going to integrate from pi over 6 to pi over 4. And now we have to be careful because secant, we know, is 1 over cosine. So we're going to do 1 over the cosine of x. And we need to close those parentheses, and then we have to actually square it because we want secant squared. And then we're going to get out of the parentheses, and we want dx, and if we hit enter, we can see that that's actually the exact same value, so we are good. We know that this is the right answer. Okay, one more that I want to do, I want to jump to number 6. This is one that we kind of already looked at in class when we did some of our antiderivative rules. So if we want the antiderivative of 4 over x, we should know that that is 4 times the natural log of the absolute value of x plus c. And we're going to evaluate from 1 to 4. All right, so let's evaluate our upper bound. That's going to be 4 times the natural log. Well, 4 is positive, so I don't need absolute value bars anymore around the 4. And then minus, now let's evaluate at our lower bound. So 4 the natural log of 1, which again is positive, so I don't need my absolute value, and then plus c. So 4 times the natural log of 4 I can't really do anything with, plus c, minus, well, the natural log of 1 is just 0, which means this whole thing, 4 times 0, is just 0, and then I have minus c. So my c's cancel each other, and I'm left with 4 times the natural log of 4. Whoops, you can't see. There we go. Now you can see it. All right, we will do 4, 5, 7, and 8 together in class before you guys jump in and start doing your own set of practice. All right, I'll see you guys later. Bye.